The human skin is a complex organ composed of three primary layers, each serving distinct functions vital to protecting and maintaining the health of the body. The outermost layer, known as the epidermis, is primarily made up of keratinocytes, cells that produce keratin, a crucial protein providing a protective barrier against environmental damage. This layer also harbors melanocytes, Merkel cells, and Langerhans cells. Melanocytes are responsible for producing melanin, which determines skin color and shields DNA from ultraviolet radiation. Merkel cells contribute towards the sensory functions of touch, while Langerhans cells are crucial for immunological interactions, linking the epidermis with the immune system. Additionally, the epidermis features openings for sweat and sebaceous glands, which secrete sweat and sebum respectively, contributing to thermoregulation and lubrication of the skin's surface. Beneath the epidermis lies the dermis, a robust layer of connective tissue that separates the epidermis from an underlying layer of subcutaneous fat. The dermis provides the epidermis with nutritional support and contains most of the skin's blood vessels and nerve endings. It's a richly endowed layer with sensory receptors that monitor environmental conditions, such as touch, pressure, heat, and cold. Like the epidermis, it participates actively in immune responses, enhancing the skin's ability to act as a protective barrier. Further below the dermis is the subcutaneous tissue, composed largely of loose connective and fatty tissues. This layer functions as thermal insulation and mechanical protection, cushioning underlying tissues and housing the larger blood vessels and nerves that supply the skin's outer layers. Functionally, skin serves as the first line of defense, preventing the intrusion of harmful microorganisms and substances. It plays an integral role in regulating body temperature, conserving essential body fluids through its barrier function, and eliminating minor waste products via perspiration. The skin is further tasked with housing sensory receptors and immune system cells, synthesizing essential chemicals and acting as a visual indicator of internal health disorders. The skin's integrity, however, can be compromised by external and internal factors, giving rise to various disorders. Ultraviolet radiation exposure, for instance, damages the epidermis leading to sunburn, while certain medications can render the skin photosensitive, exaggerating this damage. Infectious agents, autoimmune responses, and allergens can also provoke primary disorders such as acne, eczema, and urticaria. Drug-induced eruptions and chronic conditions like papulosquamous dermatosis further illustrate the skin's potential for dysfunction. In infants and children, skin disorders often manifest as lesions, rashes, and vascular disruptions. Rashes signal temporary skin responses to irritants, allergies, or diseases, while lesions indicate more serious disruptions in tissue integrity. These skin changes vary in shape, size, and content, identified through medical terms like macules, patches, papules, plaques, nodules, tumors, vesicles, bullae, pustules, and ulcers, each with distinct characteristics. Additionally, certain conditions may lead to skin thickening or character changes. Acanthosis reflects increased epidermal thickness, frequently seen in obesity and type 2 diabetes mellitus, whereas hyperkeratosis signals outermost layer thickening, often linked to vitamin A deficiencies. Ultimately, skin serves as a critical boundary between the body's internal milieu and the external environment, facilitating a host of sensory, protective, and regulatory functions indispensable for human health.